In this lesson, you'll learn to solve equations containing radicals and solve inequalities containing radicals. How do radical equations apply to manufacturing? Computer chips are made from the element silicon, which is found in sand. Suppose a company that manufactures computer chips uses the formula C equals 10 n to the 2/3 plus 1500 to estimate the cost C in dollars of producing n chips. This equation can be rewritten as a radical equation. Equations with radicals that have variables in the radicands are called radical equations. To solve this type of equation, raise each side of the equation to a power equal to the index of the radical to eliminate the radical. So the first thing I need to do to solve this is isolate the radical. So that I'm going to add 1 to both sides. So now I have the square root of y minus 2 equals 6. To undo squaring, or square root, we're going to square. They're inverse operations. So now I just have y minus 2 equals 36, and then I'm going to add 2 to both sides, and I have y equals 38. And we know, as always, we should substitute back into the original equation to check. 38 minus 2 is 36, square root of 36 is 6, minus 1 is 5. So my check step works. I'm happy with my solution. When you solve a radical equation, it is very important that you check your original solution. Sometimes you will obtain a number that does not satisfy the original equation. Such a number is called an extraneous solution. You can use a graphing calculator or GeoGebra to predict the number of solutions of an equation or to determine whether the solution you obtain is reasonable. In example 2, I've got a square root on both sides of the equation. So I can't just isolate the radical like we did on example 1. Okay, on the left side it's great because square root and squaring just undo each other. So I have x minus 12 equals, when we square a binomial, it's the first term squared. First times second times 2, so it's going to be minus 4 square root of x plus the second term squared. Okay, let's subtract x from both sides. That worked out well. Subtract 4 from both sides, and I've got negative 16 equals negative 4 square root of x. Divide both sides by negative 4. Negative divided by negative is a positive 4. And once again, square both sides. So I've got 16 equals x. Now let's check by substituting back into the original equation. 16 minus 12 is 4. Square root of 4 is 2. Does that equal 2 minus the square root of 16? 2 minus 4 is not 2. So even though we did everything right, it didn't work. I took a minute and typed the first side, the left side, into the f of x, so I just typed y equals, and then y equals 2 minus the square root of x, and you can see clearly from GeoGebra that these two graphs will never cross. The same principles we use to solve square root equations work to solve equations with roots of any index. So we're going to start off by subtracting 5 from both sides to isolate the radical or fractional exponent. And then to undo the 1/3 power, we're going to cube both sides because power of a power, we multiply exponents, and 1/3 times 3 is 1. So I just have 3 plus y on the left equals negative 125. And then we'll subtract 1 from both sides and divide by 3. I get y equals negative 42. And once again, we check by substituting back into the original equation. And wouldn't you know, 3 times negative 42 is negative 126. Seen that somewhere before. And when we add 1, we get negative 125, which we know the cube root of is going to be -5 plus 5 is 0, so my check step works, and I like my answer of -42. You can use what you know about radical equations to help solve radical inequalities. A radical inequality is an equality that has a variable in a radicand. Okay, to solve, first things first, we know that the radicand has to be greater than or equal to 0. So we can add 6 to both sides and divide both sides by 3. So we know, first of all, that x has to be greater than or equal to 2. And we can isolate the radical, so subtract 4 from both sides, and square both sides. So we have 3x minus 6 is less than or equal to 9. Add 6 to both sides. So 3x is less than or equal to 15. Divide both sides by 3, and x is less than or equal to 5. A lazy number line here, we need values that are greater than or equal to 2 and less than or equal to 5. So that makes it easy to write the compound inequality of x is between, so greater than or equal to 2 and less than or equal to 5. Now I was lazy and just grabbed a snapshot of their check step because it's kind of tedious. They picked a value, first of all, that is less than 2, so 1. And what do you know? It doesn't work. Then they picked 4. 4 is a value in this region. And 3 times 4 is 12, minus 6 is 6, square root of 6 plus 4 is 6.45. So that is less than 7. It satisfies the original inequality. And then they pick number bigger than 5, 6. And what do you know? 7.46 is not less than or equal to 7, so it doesn't work. That's the kind of check step we had to do back in the good old days before graphing calculators and now GeoGebra make life pretty easy. I graphed our square root of 3x, oops, you can't see the plus 4. There we go, square root of 3x minus 6 plus 4. And y equals 7, found the intersection, and lo and behold, they cross at 5. So this function is going to be defined between x is 2 is the lowest point and x is 5 is the highest point. So that's a nice graphical way to check. In summary, to solve a radical equation, isolate the radical, then raise each side of the equation to a power equal to the index of the radical.